Hello everyone, this is Mr. Harding going to work through the Unit 4 review. If you have been following along all year, you may have noticed that we skipped Unit 3. That's just because there's not really a review. Unit 3 more or less is a review unit by itself because Unit 3 is applications and word problems dealing with all of the content from Unit 2. So there was nothing new for Unit 3 other than just the way we looked at and handled some situations. So no review for Unit 3 other than maybe your teacher gave you your own review or he or she made one up. But that takes us to Unit 4, which in my opinion is the end of the first half of Algebra 1, at least in the order that it is taught here. Unit 4 still deals with graphing, equations, inequalities. And then when we get to Units 5, 6, and 7, it's slightly different material that we'll look at. So, without further ado, Unit 4 review video. Once again, this could be long, so just scan through to the questions that you need some help with, and if there are still things you need help with, you need to go see your teacher for further explanations. So, for Unit 4, we talked about mainly systems of equations and systems of inequalities. Well, specifically with equations first, you're looking for the point where the two lines intersect. So what a system of equations is when we are trying to find where more than one equations kind of like connect, more or less. Where do they share values? And so quickly, before we get too far, we talked about 3 instances where this can happen, and visually is one of the easier ways to think about this. If you just ask someone to draw 2 lines on a piece of paper, most likely they're going to draw 2 lines that will cross. Now, if the lines are straight, which is what they're supposed to do, that's why they're called lines, they should only touch once. You can't have a line that goes through here. That would be known as a curve, and it would be touching twice. And that's possible, but that's for much later on in math. In Algebra 1, here we're just focusing on lines which are straight by nature. And so when you draw 2 lines, they could cross, and if they do cross, it's most likely only once. They could technically cross another number of times, and that would be infinitely many. And that would be when you have a line directly on top of another line. In other words, you have the same line. Well, they touch infinitely many places. So your solution to the first line was that one point, x comma y, where they crossed. The solution to the second picture is infinitely many solutions. This fancy R that stands for all real solutions, which is where these lines overlap. And then finally, you might actually have someone who does this right away if you ask them to draw 2 lines, because it's very common. 2 lines that never touch, they're known as parallel lines, and so because they never touch, they would have no solutions. They have nothing in common other than the same slope. So we're looking for where the 2 lines intersect, and they will always intersect once, they will intersect every time, or they will never intersect, and that's where we get our 3 possible solutions. So let's start by graphing. Not only do we have 3 possible solutions, we have 3 possible ways to solve systems, and that first way is graphing, something we're familiar with. You see we've got lines in slope-intercept form. Now last unit, I had told you, the last unit review, you could probably just make 2 points, and you can make any straight line between 2 points. I like to, with systems of equations, make multiple points, and I also use 2 different colors because you typically have lines that will intersect, and so I want to see where those are. So I'm going to use blue for the top one, red for my bottom line, and what you notice is they intersect right here. So now, for the first line, where I drew many points, I needed all those points because I wasn't sure where these 2 lines were going to intersect. I don't need as many points with the red line because I found out where they were intersecting, which is my answer, by the way. Don't just stop here. Please write that answer down, 2, -1. That's the place at which these 2 points cross. Number 3, solve the system by graphing once again. But what you notice is this system has 2 lines in standard form. So I'm going to quickly move that 6x over to the other side. This is something we did earlier. Hopefully you're really good at it. I'm not going to spend much time talking through it because it should be a skill that you're good at, moving a standard form line in a slope-intercept form, because that'll make it easy to graph. And once again, what you're going to notice is I'm going to make a couple of points here, more than what I typically do, because I don't know where this other line is going to cross. So I draw all those points, I make my nice line. Now I move on to the one which I'll put in red here. I'm going to add the x to the other side quickly. That's the only step I need, and now I have a slope-intercept form, starting up at 1, 2, 3, 4, 5, and a slope of up 1, right 1. But I notice if I keep going up 1, right 1, I'm never going to hit another line. So I'm going to quickly change that, and I'm going to go down the left 1, which is the same. You can see where the 2 lines will cross. That's my answer, but I got to make sure that I write it. That would be -1, -2, because remember we always start at the origin, -2, and then up 1, 2 to the third value. So that gives us a final answer of -2, 3. Moving along. Number 4 talked about the next method that we used, and we used what was known as substitution. It's the same as a substitute teacher, a substitution in a sporting event. Any kind of substitution you make. Sometimes you guys might go out to eat, and on specialty menus, a lot of times they say no substitutions are made, or they'll tell you that you can make a substitution, but it's with an upcharge, okay? It's like any type of substitution. You are replacing that value. In order to make a substitution in math, you need to have everything equal to one value. And then if I find that value in my other equation, I can substitute it in. For example, y plus 3 is the same thing as x. So wherever I see an x, I can replace it, I can substitute it with y plus 3. So instead of having this x up here, I'm now going to write 4, and then since it's more than one term, it's a quantity, I'm going to put it in parentheses. And now I have an equation with the same variable. I can distribute and I can start to solve. What you notice is this looks like an equation from chapter 1. Right? And something that you might have heard if you were listening to me very carefully in my review video from Unit 1 is in Unit 1 we learned how to solve equations with one variable, single equations, one variable. And I told you eventually you'll learn how to solve 2 equations with 2 variables. And hopefully some of you one day get to learn how to solve 3 equations with 3 variables. And maybe even 4 equations with 4 variables. And as you start to get higher, they start to get more difficult, but there's usually always a way to figure it out. Okay? Our way here is to use either graphing, substitution, or elimination. And substitution looks to be working quite nicely for us. I combined my like terms together, I subtracted the 12 to the other side. Now I can divide by 7, and I can get y by itself, which is great, but that's not my answer, right? I never talked about on this first page here having an answer that was a single value. I need an ordered pair, no solutions or infinite solutions, and since I have a value for y, it sure seems like I'm going to get a solution. So I got to plug that back in and find out what that solution is. Plug that back in for y. -2 plus 3 is 1. That means x is equal to 1, which means I get a final answer of 1, -2. My x comma y, where those 2 lines are going to cross. Number 5 takes us to the last method we learned for solving a system of equations. It's called elimination, and it also is exactly what it sounds like. You are trying to eliminate. In order to eliminate things in math, you need to either subtract 2 numbers that are the same, or you need to add 2 numbers that are opposites, and thus they will cancel each other out. I always like to add So I always try to create opposites. As I look at my question here, you might notice 2 goes into 4. And so I can very easily create an opposite here. The opposite of 4 is negative 4. Because 2 goes into 4, thus 2 goes into negative 4, and I can easily turn this into a negative 4. Now I have to do it mathematically correct. I can't just write negative 4 here. I can't change the problem. So how can I mathematically turn that into a negative 4? Well, 2 is going to turn into this magical box and hopefully split out a negative 4. Well, what would I have to put in that magical box? I would have to multiply by a negative 2. So if I can multiply by a negative 2, which you're allowed to do in an equation as long as you multiply everything by a negative 2, now look what happens. I get that negative 4y that I wanted, and now I can add down. 5 plus a negative 8 is a negative 3, and when I add opposites, they cancel. That leaves me with just an x, and I'm able to find out what that x value is. And now I can plug this back in, and I actually have 3 options. The original top equation, the original bottom equation, and then the new equation that we manipulated. Typically, the equation you manipulate is a little bit harder to plug it in because you've usually multiplied, which means you made the numbers bigger, which means the math is not as easy. It really doesn't matter at the end of the day. If you're good at math, if you use a calculator, you'll probably be fine with any of these. But some of you, like me, like to do as much in your head as possible, and so you'll do something like I've done so far, where you can just easily plug it into the top equation. You can find out what y is, and we get a final answer of negative 1 comma 3. Number 6, a word problem with systems of equations. And you got to read really carefully. With any word problem, hopefully you've noticed that, and especially last unit being a lot of word problems. Spent a total of $94 on shorts and t-shirts, so it looks like I have 2 very different items. And it looks like there's my 94, and it looks like I have a cost for those shorts and t-shirts. The shorts specifically cost $14, so that's why it says 14y. And the really important thing here that's kind of just slid into this is that must tell me what my variable for shorts is. Shorts has to be the variable y because the 14 was paired with it. And down here in my equation, the 14 and the y go together. So shorts has to be y. T-shirts is paired with the 8, and 8 is paired with x, so that means t-shirts are x. Morris bought a total of 8 items. Well, that would be your t-shirts and shorts combined together. Here's my system. What does this mean? Well, first of all, I'm interpreting my answer, so we got to find the answer. I am a fan of substitution because I easily can find the second variable. Like what I mean by that is I look at these 2 questions, 4 and 5 here. Finding this was a little bit of work. Finding this was a little bit of work. They both involved some work to find your first value. It was the second value that I thought substitution was a lot easier to find because I already had the variable by itself. When I had to find it here, look at all the extra steps I had to move things around to do. That's personally why I prefer substitution when possible, and I think it's very easy here. I can easily isolate y, take all this stuff, plug it in for y. That gives me the equation 8x plus 14 times 8 minus x is equal to 94. I can distribute and start to solve. So we've got our 8x plus, that'll be 112 minus a 14x equals 94. I can combine my like terms, take this 112 over to the other side, and I can find out that x is in fact 3. Excuse me. That means I can easily find out what y is by plugging that in. 8 minus 3 is 5. That's what I mean, easy second step. That was easy to do. So my answer is 3, 5. So it's not C, it's not D. It's either A or B. And here's why it was important to read carefully. Short is y. Y is 5. 5 shorts were bought. 5 shorts were bought. Letter A has got to be my answer. All right, believe it or not, and it does not, I don't believe it, but this is our last page. lot quicker review. Like I said, Unit 2 review is the longest review. So you know what I'm talking about if you've stuck with me and you've watched all the reviews so far this year. So Unit 4, our last 3 questions, last page here, deal with inequalities. The other thing we talked about in Unit 4, systems of inequalities. Systems of inequalities, you can only answer by graphing, unfortunately. Don't try to do substitution. Don't try to do elimination. Some weird things can happen, and I just wouldn't recommend it. I'm sure some of you are smart enough and you can kind of talk through it and work through it, but just graph it. It's easier. The one hard part about graphing is you got to make sure that your lines are set up. So once again, something you're good at, starting to put this into slope-intercept form. So I get a negative 2x plus 3. That line's ready to graph. I'm going to get my second color here for my line in red. I'm going to subtract the x over to the other side, and then I'll divide by a negative 1. Remember, we're in inequality land here, so notice what happened to my sign. See how that changed from greater than to less than? Just don't forget about that. All right, so we've got our 2 lines. I'll start with the one in red. That's going to bring me down to negative 3. And remember how I like to use my open dots for these? Again, you don't have to, just my preference. But you do have to make sure that this is a dotted line. This should definitely be a dotted or dashed, whichever word you prefer. Dotted or dashed line. And less than tells me I would shade below this line, so down here. Okay. Blue line next, starting up here at a positive 3, and I can use my solid dots for this one. Slope is down 2 to the right 1. What you might have noticed is I didn't find out where these 2 lines intersect. That's because with a system of inequalities, you don't really care about that as much. You care about the region that they have in common, or I guess you could say the region of intersection. We're less than this line as well, which takes me down this way, and here's what I was just referring to. It seems like I have blue and red overlapping down here. This is my region of intersection. Okay, so down here. That means the possible solutions to this system are in this region. That's going to help us answer 8 and 9. Using your graph from 7, and only your graph, not algebra, no work here. Determine if 3, 6 is a solution. Well, 3, 6 would be 1, 2, 3, 1, 2, 3, 4, 5, 6. So unfortunately, 3, 6 would not be a solution. It is not a solution because, and I think I put the comma in the wrong place. It is not a solution because when you plot 3, 6, it is not in the shaded region. So you got to be in the shaded region in order to be a solution. So last question here. This is amazing. This is going to be less than half the time of our last video. Number 9, using algebra this time, determine if 3, 6 is a solution. We did do a question very similar to this last review, but it was a linear inequality, not a system of linear inequalities. So I need to take this, but I've got to plug it in for both inequalities because I want to find the answers for both. Like for example, right here, this point that I'm making right now, I'll put an X through it, I'll put a fancy star through it. That is a solution to the blue line. But it's not a solution to the red line, which is why it's not a solution to the system, because the system is both lines. That's why I need to check both lines. So here's my first line when I plug in my 3, 6. And I do the math for this. That's 18 plus another 18 less than or equal to 9 is 36 less than or equal to 9. Now here's where I don't have to check both of them. This is already false, so I don't even have to check the other one. I know 3, 6 is not going to work because it already didn't work. So it's not a solution, and my work right here shows why. It's not a solution, exclamation point, that's important, and that's why, because it didn't work. Okay, so Unit 4, all about systems. There's 3 different answers. There's 3 different methods, graphing, substitution, and elimination. They can help you find whether you have infinite solutions where the lines overlap, no solutions where the lines never touch, or one solution where they'll cross. And then we also have systems of inequalities, which we focus on the shaded region. Okay? Thanks for joining. A lot quicker video. Hopefully you watched it all if you needed to. And as always, ask your teacher questions if you need more help.